Of you here. Welcome to Vedavyasa Academy. In this session, we discuss about the conic sections. What is conic section? How to generate the conic section and equation of the conic section. In this session, we discuss. Here, what is conic section? What is conic section? Generally, conic curves are generated by intersection of plane and double cone. Okay, in different orientations. Okay, all of you, these curves are generated by intersection of plane and double cone. How to generate? You see, all of you, so this is the line, this is the another line. This makes an alpha angle with a constant line. That is generated line. Here you observe here, this is the this one. Here this is the double cone. Okay, all of you. Here suppose a plane intersect like this. A plane intersect like this. Then here are one conic section is formed. This one. Okay, all of you. This conic section is a circle. This conic section is a circle. So you go further, other intersection of plane with double cone. You see, this is the generator line and this is the like this. Okay, all of you. Suppose like this intersection of plane. This is the plane intersection. Then here one curve is formed like this. In this case, we say this is the ellipse. This curve is ellipse. Another one, you see, all of you. This is the generated line of the cone and okay. Here this is the one plane cuts the here one curve is formed like this. This curve is parabola. Like this, curves are generated by intersection of plane and double cone in different orientations. Here, like this, different curves are formed. Okay, na? So here you see another one. Suppose the graph, you draw the graph of here ax square plus 2hxy plus by square 2gx plus 2fy plus c is equal to 0. This is the quadratic equation in two variable. You draw the graph of this one, you will get the conic section. Okay, all of you, curve of the conic section, the graph of the quadratic equation, the graph of the quadratic equation. Quadratic equation in two variables. Two variables also represent the conic section. Also represent the conic section. Okay, all of you. Curves are generated by intersection of plane and double cone in different orientations. Formed a conic section. Conic sections. Conic sections. So, like this. This is the double cone. This is the double cone. This plane is cut like this. This plane is cut like this. This plane is cut like this. This is the a circle, ellipse, parabola. Similarly, hyperbola is also formed like this. Locus of the point. Locus of the point P in a given plane. Suppose this is the fixed point S. This is the fixed point S and this is the fixed line L. This fixed point S is the focus. This is focus. This is focus. And this is the directrix. Okay, all of you. So, this is the point P. This is the point P. We have to find the locus of P. So, how to find? This is the ratio distance between fixed point to point P, and this is the perpendicular distance from P to line L is PM. Perpendicular distance. Perpendicular distance from P to line L. Line L is PM. Okay, distance between from a fixed point S to P is SP. Then the ratio of this is SP by PM. SP by PM is constant. Locus of P is ratio of SP by PM is constant. Locus of P, the ratio of SP by PM is constant. So, SP by PM is equal to constant. This is equal to E as eccentricity. It is noted as eccentricity. And eccentricity, the locus of P is called a conic section. Locus of P is called conic section. Okay, all of you. Here, perpendicular distance from P to this line is line L is PM, and the distance between from the fixed point S to point P is SP. The locus of P, then the ratio of SP by PM is constant. That is, SP by PM is equal to constant. This denoted as E is the eccentricity. Locus of P is called conic section. So this fixed line is called directrix. Fixed line L is called directrix of conic section. of conic section, and this fixed point is called fixed point. Fixed point is called this is focus of the conic section. Conic section. Okay, all of you. In this conic section, two focuses are there. Foci are there. This focus points, every conic section focuses are two real focus foci and two imaginary foci. Two real foci and two imaginary foci. So, like this, two directrices also is there. Two directrices, two real foci and two imaginary foci. Okay, this two real foci is there. Like this, two directrices are there. Two directrices are there in conic section. In conic section. Okay, all of you. Here, SP by PM. SP by PM is equal to constant, that is E. E is known as eccentricity. This ratio is equal to constant. Constant is eccentricity of the conic section. Okay, all of you. This is the conic section. Understanding of the conic section. Important notations in conic section. What are the important notation? First one, focus. So, focus. Focus is a fixed point in conic section. Focus is a fixed point in conic section. Conic section. Okay, all of you. Another one is this line L. Line L is fixed line. This is line, that is directrix. Directrix. Okay, all of you. This directrix is a fixed line. Directrix is a fixed line. Fixed line. Okay. Next, axis. So this is the axis. So third one is axis. Axis. Axis of the conic section. Axis of the conic section. This axis passing through the focus and perpendicular to the directrix. So axis, the line passing through focus and perpendicular to directrix is a axis of conic section. Axis of conic section. Okay, all of you. Next, the fourth one, you see. Fourth one, vertex. Okay, what is vertex? Vertex of conic section. So, vertex is the intersection of the point. That is intersection of the point, axis and that curve, axis and this one, axis and this locus of the P. So the intersection point of axis of the conic of the conic section. Conic section and locus curve. Locus of P curve. Okay, this is the vertex of the conic section. This is the vertex of the conic section. Fifth one, this is axis completed, vertex completed. Next, that is focal chord. This is focal. This is double ordinate. Double ordinate. Okay, all of you. Double ordinate. Double ordinate is a chord of the curve. Is a chord of the conic section. Conic section perpendicular to axis is a double ordinate. Sixth one, lattice rectum. Lattice rectum. Lattice rectum is a chord, longest chord. The lattice rectum is a chord which passes through the focus. Lattice rectum is a chord passing through focus and perpendicular to axis. Okay, this is the lattice rectum. Okay, all of you, this is lattice rectum. Next one, center of the conic section. Seventh one, center. The point which bisect chords of conic section is center. Okay, this is the center of the conic section. Next, focal distance. Focal distance is the distance between focus to any point on the curve, any point on the conic section. So, focal distance is any distance between focus to any point on the curve is a focal distance. Then after, very important point, eccentricity. We know eccentricity. We already know the eccentricity. What is eccentricity? Eccentricity, here SP by PM is a eccentricity of the conic section. SP by PM is equal to eccentricity. This eccentricity is important in conic section. Suppose this eccentricity value is equal to 1. That conic section becomes a parabola. The conic section is parabola. Okay, all of you. Second one, this eccentricity lies between that is 0 to 1. That is E0 less than E less than 1. Then that eccentricity is ellipse. Ellipse. That curve is called a ellipse. That conic section is called a ellipse. Third one, E greater than 1, that conic section is called hyperbola. Hyperbola. Next, fourth one, E is equal to 0, that conic section is a circle. That conic section is a circle. Next, fifth one, if E is equal to infinity, eccentricity is equal to infinity, that conic section represent pair of straight line. Pair of straight line. You remember, all of you, if E is equal to 1, the parabola, it represents the parabola. E value 0 less than E less than 1, that conic section represents the ellipse. If E greater than 1, that conic section represents the hyperbola. If E is equal to 0, that conic section circle. E is equal to infinity, that conic section represents the pair of straight line. Once again, we discuss, we repeat all the notations. First one, focus. Focus of the conic section. Second one, directrix. What is directrix? We already discussed. And third one, the axis. Fourth one, axis completed. Fourth one, latus rectum. And fifth one, double ordinate. And sixth one, this is vertices or vertex. Next, seventh one, focal distance. Eighth one, center of the conic section. So in center, you observe one point is there for center. Here, this center, parabola have no center. And only ellipse and hyperbola and circle have the centers. Parabola have no center, and ellipse, hyperbola, circle are center. So this is the very important notations in conic sections. So what are the conic sections? Parabola, ellipse, hyperbola, circle, pair of straight lines. These are the conic sections. When plane cuts the double cone, these are the formed. So what is the equation of the conic section? Equation of the conic section is in the form of quadratic equation, quadratic equation in two variables. Okay, that is in like this: ax square plus 2hxy plus by square plus 2gx plus 2fy plus c is equal to 0. The graph of this is the conic section, or the locus of the P, like SP by PM, is constant ratio, is a conic section. Okay, all of you. So these are in the same plane. So plane cuts the double cone, we will get the different type double cone. Plane cuts in different orientations double cone. Then we will get the different conic section. That conic sections are parabola, ellipse, hyperbola, circle, pair of straight lines. So these equations represent like this: ax square plus 2hxy plus by square plus 2jx plus 2fy plus c is equal to 0 is represents the conic section equation. Okay, all of you? That's all.